Welcome to another episode of Built by Sarah, where we are built by discipline and powered by purpose. So today I want to talk about building real-time AI automation in enterprise systems. What it actually takes. What people think versus what it actually is. When people hear AI or real-time automation in enterprise systems, they often imagine something clean. A model makes a prediction, a system takes an action, everything just works automatically, but that's not reality. In large companies and enterprise environments, you're not building AI in isolation. You're building AI inside legacy infrastructure, regulatory constraints, operational risk environments, and systems that were never designed to think in real time. So the real job of a principal architect or engineer isn't just building intelligence. It's building trustworthy intelligence inside systems that were never designed to be trustworthy. And here's the core reality. You're not building models. You are building systems of consequence. At this level, AI is more than just a feature. It's a decision layer. And every decision has a real-world consequence and impact. Grid load changes, energy distribution adjustments, customer billing implications, operational automation triggers, compliance, and audit trails. So the architecture has to answer a harder question than does it work? It has to answer what happens when it's wrong or fails at scale in real time under a real load. Because real time means that everything is a constraint. Real-time automation in enterprise environments is not just about speed. It's about coordination under constraints. Latency, budgets across distributed systems, data freshness across multiple ingestion layers, event consistency across microservices, reliability under peak load conditions, fail-safe behavior when upstream systems degrade. You're not optimizing for one thing. You are balancing everything at the same time. And every decision becomes a trade-off between speed, accuracy, cost, safety, and regulatory compliance. And what you actually spend your time doing as a principal architect is not what people think you're doing, which is designing systems. But what you're doing is translating reality between logic layers. Business, we need automation and efficiency. Engineering, we need deterministic behavior and control. Data, we need consistency and clean signals. Security, we need auditability and zero trust enforcement. Operations, we need to break at 2 a.m. And in the middle of all of that, you are designing the system that all of them can live in safely. AI in this context is not autonomous. It's constrained intelligence. In enterprise systems, AI cannot just decide. It must operate within guardrails, emit explainable outputs, integrate with deterministic fallback systems, and remain observable at every layer. So the architecture and engineering becomes less about what can AI do and more about what is AI allowed to do safely, repeatedly, and predictably. Real-time automation is an event system, not a model system. The real foundation of these systems is not the model. It's the event pipeline. Everything is driven by streaming data ingestion, event correlation, stateful decision engines, and distributed execution layers. AI becomes one node in a much larger cog. So a cog in a wheel, or a cog within a cog. And the intelligence layer sitting on top of real-time event orchestration. If the event layer is weak, the AI doesn't matter. If the event layer is strong, the AI becomes very powerful but controlled. The hardest part is legacy systems never die. They just become more constraints. And in large companies, you are always integrating with systems that were built decades ago, were never designed for APIs, were never designed for AI or automation, and cannot be replaced without risk. So the architecture challenge becomes not how do we rebuild, but how do we modernize without breaking operational continuity? That means abstraction layers, translation layers, parallel execution paths, and gradual trust migration into new systems. The role of the principal architect and engineer is you're more of a risk translator. At this level, you're not just designing software. You are translating risk across domains. Engineering risk, system design decisions, business risk, automation boundaries, data risk, model reliability constraints, operational risk, failover strategies, compliance risk, audit architecture. You are constantly answering where is it safe to automate and where is it not. The hidden truth. The best systems are not the most advanced. They are the most contained. In enterprise AI systems, success is not about maximum intelligence. It is about controlled intelligence, observable intelligence, reversible intelligence, and governed intelligence. Because at scale, unpredictability is more expensive than inefficiency. So in closing, what this work actually means. Building real-time AI automation in energy and enterprise systems is not just technical work. It's structural work. You are designing systems that sit inside critical infrastructure. Systems that cannot fail silently, cannot behave unpredictably, and cannot drift outside of governance constraints. So the real measure of success is not how advanced the system becomes. It's how safely intelligence can be introduced into environments that were never designed for it. And here's a final thought. At this level, you stop asking, can we automate this? And you start asking, what does it cost us, technically, operationally, and ethically to automate this? And that is where real architecture and engineering begins. Thank you for another Built by Sarah Talks, where we are powered by discipline and purpose. I don't know. I think we're built by discipline and powered by purpose, but I'm still getting used to that new tag. I'm so used to, thank you for another Sarah Talks Tech. I think I should do Sarah Talks Tech for the Sarah Talk Techs, for the Sarah Talks Tech Talks. That's a tongue twister, but have a good night.